All right. It's your man Jimmy Chan over here. All right, today we're going to have somewhat of a shorter lesson. So this one is on slope of lines, right? So you know two equations of a line. One is y is equal to mx plus b, which is also known as the slope intercept form. And then the other one is called the point slope form, which is y minus y1 is equal to m times x minus x1. This one is called the point slope form. Okay, so if you notice that the point slope form needs a point and a slope, which the point would be your x1 comma y1 and your slope would be m, right? And over here, let me even do it this way. This will probably be even better. Blue, and blue. Okay, and then your M. Okay, actually let's stay with that theme with the M here. And then your y-intercept. There we go. All right. So the slope intercept and the B is actually your y-intercept. Okay. There we go. All right. So no matter how you look at it, to get an equation of a line, you need the slope. So the question is, how do we find slope? Well, you guys done it before. You guys go, well, slope. Couple of things that we know about slope, right? We know that slope is rise over run, right? So if the rise was positive, then we go up, and if it was negative, we go down. And if it was positive, we go right, and the run is negative, then we go left, right? So that's one thing about slope that we know. We also know that slope is y2 minus y1 over x2 minus x1. Okay? Now that we learn function notation, right? Now that we know function notation, what else would you replace the y's with? That's right. You would replace it as f of x2 minus f of x1 all over x2 minus x1. Okay? So realize that this form right here is exactly the same as this form right here.
Sorry,
okay?
I can't do that right now.
So realize that those are the same exact forms, all right? So with that being said, now chances are they're going to talk about with this one as rate of change, right? While they're going to just call this for you to find the slope, okay? Which the slope is the rate of change. Okay, those two mean the same thing as well. Rate of change and slope are the same thing. All right, so from there, You know what? I'll keep it simple. Let's do this. Let's say I want you to find an equation of a line that goes through the points -7, -3, yeah, I'll just make it up, and -5 -7. Let's try that, okay? So in this case, then what you know is that, okay, so I got 2 points, right? I got X and a Y. So one of the things that I say is to make things easy, because you know you're gonna have to use one of these two formulas, that what you would do is go, okay, so I'm going to stack these two. All right, and when you stack these two, this is what happens. I can do this over that. Let me make that a little smoother. Over that, right? Because all I want to do right now is say, okay, M is equal to y2 minus y1 over x2 minus x1. And here's the biggest part. The 2 and the 1, the subscripts, are just talking about staying in order. Now, some of you nursing majors might want to say, oh, it's the final results minus the initial results, which is fine. So I'm going to do it both ways and show you that it really doesn't matter, okay? So let me move this up a little more. Give me some space. All right, so if I do it this way, I'll say, ooh, it's -3 minus a -7 over 7 minus 5. All right, so if it's a -3 minus a -7, what do I have? I'll have a 4 over 2, which gives me 2. All right, so let's say I flip it the other way, right? Let's say that I decide that I'm going to put this up here instead, right? If I do it that way and brought it down, then what I would have now is, oops, forgot that. There we go. So now what I would have is -7 minus -3 over 5 minus 7. Okay, let's see what that goes, how that looks. So I got 7 plus a 3, which is -4, over 5 minus a 7 is -2. So that will also give me a +2. Voila. Okay, so now I have my slope. Okay, so my slope is equal to 2. So what do I need in order to write an equation of a line? I can use both of these. Both of these will work, and I'll show you both ways. So the slope-intercept form, I tend to call it as the SIF, or the SIF, slope-intercept form. And the point-slope form, it would be PSF, okay, for point-slope form. So let's do both. I'm going to go ahead. So, but either one, I'm going to also need a point. Okay, because in the slope-intercept form, I do have an x and y in it. And in the point-slope form, I do need a point. So I just got to pick a point. Whichever one doesn't really matter. Let's say I pick 7, -3. Okay, just for poops and laughs, let's do that. So let's go ahead and do the point slope form, the PSF. Okay, the point slope form says y minus y1 is equal to m times x minus x1. Okay, so notice I put it in there, and notice that the red negative was part of that formula of the point slope form, and the -3 that I put in there is actually from the point. Okay, so realize that. All right, so what do I have? I got y plus 3 is equal to, yes, I do have to distribute here. So therefore I get 2x minus 14. Then I gotta subtract the 3 over. So therefore I have y is equal to 2x minus 17. Okay, so that's the PSF. Boom, done. All right, so let's take a look at what if we use the SIF. Okay, if we use a SIF, we have y equals mx plus b, right? So, okay, so y here is -3 is equal to m2 times 7, which is x, plus b. Okay, so what do I have? I got -3 is equal to, I was about to put 9, but it's not 9. It is more like 14 plus b. To get b by itself, I got to subtract the 14. So b is equal to -14. So great. So what I have here is that I have the y-intercept, and I also have the slope being 2. So now I can just rewrite the equation of y equals mx plus b. Oops, made a mistake. Subtract 14 would not be 14. It would be more like 17. There we go. Now you notice that either way I do it, I'm still getting the same exact equation. And you're like, well, why did you do it both ways? Well, here's the thing, is that the point slope form is going to be brought up, so you should remember it. However, it doesn't mean that and you're so familiar with the slope intercept form that I would tell you to use the slope intercept form because you're so used to it, okay? Where the point slope form, it will ask for it, but you're not that familiar with it, so that's why I like to show both ways. So if you have a question about, hey, how do I remember the point slope form? Let me put it on the side for you, all right? So we know the slope formula is this right here, right? So if I look at that, m is equal to y2 minus y1 over x2 minus x1, right? All right, so I can make the m a fraction. So right now I have a proportion here, which means a single fraction equaling a single fraction. So that means I can actually cross multiply. Okay, if I cross multiply, what do I get? Well, let me do it this way. This times that would give me 1 times y2 minus y1, and then that is going to equal to this times this would give you that. So m times x2 minus x1. All right, so if you notice, if I distribute a 1 through, what's going to happen? Right, nothing. And then look at this. Let me see if I can do that. Boom, boom, and now there is my point slope form. Okay, so that's one way to remember how to do it because it's already there, part of your slope intercept form. Your slope formula. Okay, so there you go. So what's the next thing they're going to bring up? They're more going to bring up, you're going to see more of this. I figured I wanted to just be able to use the PSF and the SIF to show you how to write the equation of a line. But the question that they're going to ask you more of is going to be, they're going to ask you something more like this. So they're going to talk about more about the parallel and perpendicular. Okay, so parallel and perpendicular. What makes it parallel and what makes it perpendicular, it all depends on the slope, right? Depends on slope. Okay, so let's say the slope of the original, and then we're going to say what's the slope when it's parallel, and that's a symbol for parallel. Let me put down parallel here. And the slope that is perpendicular, and that is a perpendicular symbol. Okay, so if the original slope, let's say, is 3/4, okay? So the parallel slope would be exactly the same, still 3/4. But if it's perpendicular, right? So if we think about perpendicular lines here, okay, what you would notice that if the red is the original and the black is the perpendicular line, what you're going to notice is that one is going to be, the red is going to be positive while the black is going to be negative. So you know that we have to flip the sign, right? So the perpendicular would be -4/3. So it's actually a flip. Here, rewrite that. It's going to be a flip and negate. Okay, that's what you're going to want to do. All right. So if the original was -1/2, then parallel would be -1/2. What would be perpendicular? Well, if I flip 1/2, it'd be 2/1, which is just 2. And if I negate a negative, it'll become a positive. So it would just be a 2. All right. So that would be an example of what it would be there. Okay. So hopefully that helps. So the question that it's going to give you is going to be this way. It's going to say, write an equation of a line passing through -9, -8, but it is going to be perpendicular to y equals -2x plus 1. Okay, so here is more of the equation they're going to talk to you about. So here is the part that I want you guys to understand. So in order for me to write an equation of a line, I need a slope and a point, okay, or a point and a slope, okay? So I have my point, -9, -8, but I don't have my slope. So this piece right here is telling me, hey, oops, undo, make this thick again. This right here is telling me this is where I will find my slope, okay? So essentially what you're going to do is you're going to take that and go, okay, so now notice that I'm not focused on anything else but this piece right here, all right? So I go, okay, so y equals -2x plus 1. I know what the slope is. The slope here of this line is -2, okay? So now the question is, what is the slope that is perpendicular to that? Well, I will have to flip and negate. So if I flip 2, what would that be? It'd be 1 over 2. If I negate the negative, it'll become positive, okay? So now that I have my slope that I need, because I just need to be perpendicular to this line, right? So I have the perpendicular slope. I got what I need. So now what you have to understand is the rest, this part right here, no longer matters anymore. You can just take that piece out. It is gone. I don't even need to know it's there anymore, okay? So now I can go back and say, okay, now let's deal with this piece, all right? Now, obviously, I don't want to black that out for the notes, but I am going to, however, at least do this. So all I need is that piece and this piece. All right, so these are only 2 pieces of information I need. All right, so I'm going to use those 2 pieces of information and get the equation of a line. So let me see here. I'm going to go ahead and do it as a PSF. Okay. As a PSF, so I can go, all right, so I have, I know what I want to do. Let's do that in red. PSF, so I have y minus y1 is equal to m times x minus x1. Okay? So notice the y got to the y, the x got to the x, and the m got to the m. All right? So now I got to finish this. So this is going to be y plus 8 is equal to 1/2 x plus 9/2. Okay? Then I got to subtract the 8. I guess you know what? Let me add some steps here so that you guys don't get confused. Let me do this. This is going to be y plus 8 is equal to 1/2 times x plus 9. And yes, I do have to distribute here. Okay, so now I got y plus 8. When I distribute the 1/2, I'm going to have 1/2 x. And 9 times 1/2 is just going to give me 9/2. Because when multiplying fractions, top times top, bottom times bottom. Okay, now I have to subtract the 8. Okay, so when I subtract the 8, what happens? Okay, so let's do this. Let's take this right here, and let's take this piece right here and do it on the side. Okay, so what I have is 9/2 minus 8 over 1. I need a common denominator. Okay, so what does she have that I don't have? Well, this one needs a 2. So what I have here is 9. Oh, you know what? Let me do it this way even. Just use up the room. So I got 9/2 minus 16/2. What does that equal to? That would equal to negative 7/2. Yep. Okay. So then the equation would be y is equal to 1/2 x minus 7/2. Okay. So this is what it would be if it was just an equation of a line. This equation of a line, if it was in the slope intercept form. Okay, great. So that would be that. However, wow, struggle bus. All right, so there's my equation of a line in slope-intercept form. Now here is the issue. What if they are only asking you to keep it in the point-slope form? Well, the point-slope form, let me do it this way. I think blue would be great. Okay, so what if they want the point slope form? Okay, well, perfect. Well, here's the good news about point slope form is that you don't have to go into all that trouble. You can leave it right here. Okay, even before you distribute, you can just bring that down and use that. So you have y plus 8 is equal to 1/2 times x plus 9. All right, so that would be your point slope form. There you go. All right. So sometimes they'll ask you in slope-intercept form, and sometimes they will ask you for point slope form. All right. Now the other thing I want to add is this. Let's go back to the red marker here. What if they want function notation? Now they won't ask it in here because there's no way of doing it, but what if they ask you for function notation? No, I don't know. Well, remember, everything stays the same in function notation. The only difference is that you're going to replace the y with f of x, and that's it. Okay, so that would be function notation. Okay, so you will be asked for that for sure. All right, so anyways, I think this is it. If there's any questions that you might have, remember that, you know, x comma y is just a point. All right, and we'll go from there. If there's any questions, let me know. See ya.